Okay, now we're on chapter 2-6, where we will continue to perform operations with multi-digit whole numbers and with decimals to hundredths. We're going to divide by two-digit divisors, which is very similar to what we did in 2-5. So much so, in fact, that I rewatched the 2-5 before making this video to see what kind of information I want to add or things that I wanted to probably change as I have a second shot to describe this lesson. One thing I really noticed was how organized our notes were for 2-5. And even though it was very time consuming because we were writing out almost all the multiplication facts for the divisors, 36, 55, 18, 24, doing so many of them, we multiplied it by 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It took a lot of time. Like, one problem took 15 minutes, but it was worth it because everything made sense, and there was no, oh man, where was the mistake? There was an easy, okay, this is where the numbers came from. So I just want to encourage you, before even starting the video, that this process does take a while, but it's worth the journey. And it's worth doing it right the first time, rather than getting confused and not being able to explain it really well. That being said, we're going to start number 2. And we're going to write this out left to right, labeling the different sections. 837 is your dividend. 36 is your divisor. And we're looking for the quotient. We're going to divide and check our answer, which is very similar to what we've been doing throughout all of division. We'll check our answer using multiplication. The dividend, the first number, goes inside the house. So we're going to put 837 here. And 36 is going to go to the side. We're going to say, just as we did in the past, 36 times what number gets close to or equal to our first digit, 8, without going over. And what I like to do is I like to have 2 rows. And if you looked at 2-5, you'll have noticed this pattern, but this time I want to make it more explicit. Explicit meaning, this is what I expect. We're going to start with 36 times 0, 36 times 1, and 36 times 2. And you can see that I'm writing these left to right, just on the side of our division. Our division problem. And this is something I don't want you to erase. So when I give you the work tomorrow, and as we start doing it in class, I'm going to give you a binder paper, and I'm going to ask you to write all of this out without any erasing, without any doing it at the margins, and I want it to look nice and neat. That being said, 36 times 0 is 0. 36 times 1, because of the identity property, is the number it started with itself. And 36 times 2, you can use your cheat sheet for. You're going to do 2 times the 6. 2 times 6 equals 12. We're going to regroup the 1. Then we're going to do 2 times 3, which is 6, plus the 1, which is 7. So we have 36 times 0, 1, and 2, with the answers being 0, 36, and 72 respectively. Respectively meaning in that order. Now we're going to ask ourselves, 36 times which of these numbers gets close to or equal to 8 without going over? So we're just looking at the first digit, the 800, the 8. And you can see here that 72 and 36 are too much. So we're going to have to use the math fact 36 times 0. 36 times 0 equals 0. 8 minus 0 is going to be 8. Now, before we bring down the 3, which is the next step, we're just going to compare to make sure that what we have left over is less than our divisor. If this number is bigger, we made a mistake somewhere. We have to adjust the quotient. And, the number that, this number right here, our quotient that we're using, that we're multiplying by 36 times what number? But since 8 is smaller than 36, we could bring down the 3. Now you can see here, having written this out already, we're already on a good track. we could see that 36 times 0 and 1 are a little too small, but 2 is getting kind of close. 36 times 2 is 72, which is kind of close to 83, but let's, just in case, go to the next one, because we want to make sure to, that 36 times this number is either equal to or less than, and right now it's just less than. We don't know if the next one's going to be equal to. So let's just keep going until we actually pass it using multiplication. That way we could feel confident in our answer. If you notice, I like to put my math facts in order. And you can see I'm doing 36 times 0, 1, 2, 3 in that order. And then in the last video, every time I did 36 times 5, I started a new row. So you'd see me do 0, 1, 2, 3, 4 on top, and then 5, 6, 7, 8, 9 on the bottom. That being said, to multiply 36 times 3, I'm going to multiply 3 by the 6. 3 times 6 is 18. We're going to regroup the 1. And we're going to do 3 times 3. 3 times 3 is 9. And we're going to add the 1. 108. So here, we're saying, buddy, 36 times what number gets close to or equal to 83 without going over? And our answer so far is 0. That's too little. 36 is still kind of small. 72 is getting closer, and 108 is too much. So the one that gets closest to 83 without going over is 72, because this one goes over, and that's still too little. So we're going to use the math fact 36 times 2 equals 72. Ooh, bless me. And the way that that's going to work out is 36 times what number? 36 times 2 is close to or equal to 83 is 72, which is the closest we could get to 83 without going over or being too little. And when we subtract, 3 minus 2 is 1, 8 minus 7 is 1. And even though this is a double digit, all we have to do is compare it to the divisor, really. And because 11 is less than 36, we know we're still on the right track, and we can bring down the 7. Do double check before bringing down the next number that this is less than your divisor. This meaning your remainder before putting it down. Now we're getting close to 117. You can see here that the answer so far is 0, 36, 72, 108. So when we're saying 36 times what number gets close to or equal to 117, the cool thing is we're kind of already close. 108 is kind of close to 117. But just in case, let's do the next number, which is 36 times 4. If you look at your 4s, you're going to start with 4 times 6. 4 times 6 equals 24. We're going to regroup the 2. Next, we're going to do 4 times 3. 4 times 3 equals 12, plus the 2, 12, 13, 14. Because the number after 12 is 13, and we're adding 2, 13, 14. Now we can see that 117 is, we're asking ourselves 36 times what number is closer or equal to 116, and we wrote up the math facts for 0, 1, 2, and 3, and 4. 0 is too little. 36 times 1 is a little too little. 36 times 2 is too little. The answer 108 is getting close, and 144 is too much. So at this point, we're going to use 36 times 3. Because 36 times which of these numbers is closest to 117? These 3 are too small. This one's closest to 117, and that one's too much. And we don't want to go over. 36 times 3 is 108. 36 times 3 equals 108. 7 minus 8, we'd have to regroup. The 1 becomes a 0. The 7, because we borrowed from the tens place, is 7 plus 10, which is 17. 17 minus 8 is 9. 0 minus 0 is 1. 1 minus 1 is 1. Since there are no more numbers to bring down, we could circle this, and this is our remainder. Remainder 9. And so here's our final answer, 23 remainder 9. The answer to division problem is called our quotient. 23, remainder 9. And our last step is just to double check our answer. So unlike the other problem that I did for 2-6, last time we had to write out not 36, it was 18, but we had to multiply it by 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This one we only had to do 0 through 4 because that's the way the numbers work out for this specific problem. But don't be intimidated, don't be afraid, and don't think it's a waste of time to have to write all of them out. It's, like I said, it's better to do it the right way and to know where all the numbers go than it is to just put in the margin and erase it. And you don't know where your mistake might have been. Plus, when we're going over in class, I can look at it and see where you might have gotten stuck. That being said, let's go ahead and double check our answer using multiplication. You could either do 36 times 23 or 23 times 36, the reason being the commutative property of multiplication. I'm going to put 36 on top for me, and then I'm going to multiply by 23. You could have done it, like I said, with a 23 on top and a 36 on the bottom. That's perfectly fine. You'll get the same answer, just a different process. 3 times 6 is going to be the first one we do because we're going to multiply the bottom right number 3 by all the numbers on top. So we're going to start at the bottom 3 and multiply by the 6. Looking at my cheat sheet, 3 times 6 is 18. The 8 goes here, and we're going to regroup the 1. Then we're going to continue multiplying the bottom right number, the 3, by all the numbers on top, going from right to left. Since we already multiplied these two, we're going to multiply 3 by 3. 3 times 3 is 9, plus our 1, 10. And we're going to cross this out, and we're going to go move on to our second number right here. Our second number on the bottom is 2. But since this is actually a 20, because this is 23, we're going to put our second number, second row, and put a placeholder 0 here. So once we start multiplying by the second number, we're going to start a second row, and we're going to put a placeholder 0 because this isn't really a 2, it's a 20. So this 0 has a value, but we're just going to shift our numbers over here. Now we're going to multiply 2 by the first top right number, which is 6. 2 times 6 equals 12. And we're going to regroup. The 2 is going to go here for the 12, and the 1s, and the 10s, which is the number 1, is going to go to the next number we're going to multiply. So the next number we're going to multiply is 2 by 3, so we're going to regroup that 1. So if you look at that again, 2 times 6 is 12. I put the 1 on top of the next number I was going to multiply by, and I put the 2 underneath the second column. Now we're going to multiply 2 times 3. 2 times 3 is 6, plus 1 is 7. And we're going to add. 828 is our answer so far, and if you ask and say, hey, that doesn't equal our dividend yet, it's because we still need to add our remainder. So add our remainder 9. To do 8 plus 9, what you could do is start with 9 and add the 8. So the number after 9 is 10, and we're going to use our 8s. 10, 11, 12, 13, 14, 15, 16, 17. Let me show you how I got 17 again. I started with the number 9 in my head, and I thought the number after 9 is 10. So the first time I touch a number on touch math, I'm going to say 10 because that's the number after 9. I'm adding 8, so I look at the 8s. 9, 10, 11, 12, 13, 14, 15, 16, 17. You could have done it the other way where we start with 8 and say the number after 8 is 9, and this time look at the 9s. So if you want to do it that way, we think of the number 8, the number after 8 is 9, and then when we look at the 9s, 9, 10, 11, 12, 13, 14, 15, 16, 17. Either way we get 17. 2 plus 1 is 3, 8 plus 0 is 8. 837 equals 837. I'm going to do one more problem, and then after that we'll start the word problems together. The second one is 1,650 divided by 55. Alright, where we label our dividend and our divisor. And we're looking for the quotient, which is the answer to a division problem. The dividend is going to go inside the house, quote unquote. And our divisor is going to go to the left. I'm going to ask ourselves, buddy, 55 times what number gets close or equal to 1 without going over? So 55 times, we're going to start with 0, 1, and 2. I'm sure a little messy, sorry about that. I know. Okay, 55 times 0 is 0. 55 times 1 is 55. If you've seen, it's always a pattern. The first number times 0 is always going to be 0. The first one times 1 is always itself, because of the identity property of multiplication in terms of the 1, and then anything times 0 is 0. Then we can do 55 times 2, and we can use the cheat sheet to help us. Since the bottom right number is 2, we're going to be looking at our 2's. We're going to start with 2, it's bottom right 2, times the first 5 at the right side. So 2 times 5. 2 times 5 is 10. We're going to put a 0 here and regroup the 1. Then we're going to do 2 times this 5, the one in the tens place. 2 times 5 is still 10. And we're going to add the 1, which is 11. So when we're saying 55 times what number is close to or equal to 1, you could see 0, 55, and 110. 1 is very close to 0, and 55 and 110 are way above. So 55 times 0. In other words, if you have $1,000 bill, you cannot give it to 55 people without decomposing it into hundreds. So let's go to the hundreds, which is the 6, and bring that down. And before we bring it down, 1 is smaller than 55, so we're on the right track so far. 55 times what number is close to or equal to 16 without going over? You can see our first answer is 0, still too little. 55, already too much. So again, we're going to be using 0. Because if we have 16 of something, and in this case it's $1,600 bills, we can't give it to 55 people without decomposing it even more. So again, 55 times 0 is 0. We're going to subtract, and it's still 16. Not still, it's 16. 16 is less than our divisor, which is 55. So we could bring down the 5. Now at this point we're getting closer. 55 times 0 is 0. 55 times 1 is 55. It's closer to 165. 55 times 2 is 110, and that's getting a lot closer to 165. Let's see what happens when we do the next one. 55 times 3, because 110 is somewhat close to 165. We could look at our 3's here. 3 times 5 equals 15. Regroup the 1. 3 times 5. So the first one we did was 3 times this 5, and we regrouped it. Now we're doing 3 times this 5, which is still 15, but this time we're adding the 1, 16. We have a perfect number in terms of it being 165 exactly. So we don't have to go to the next one. We could stop when we have exactly. If it's still too little, keep multiplying it out until we overpass it, because we want to know 55 times what number gets close to or equal to it without going over. 55 times 3 is exactly 165. And that's 0. 0 is less than 55, which is the divisor, so we could bring down the next one. Now this is the most important step. This 0 does have a value. It's in the ones place. So 55 times what number gets close to or equal to 0 without going over? You do have to use this math fact here. 55 times 0 is 0. Now, some people might have neglected it and just put 3 as your answer. But no, you need to make sure that you have a digit on top of each place value. And this 0 does have a value, okay? So when you brought it down and you said 55 times, and then you brought it down, you still have to do this last step. 55 times what number equals this without going over, and if it's 0, you still have to put that value there. And this 0, at this case, has no number to bring down, so this is our remainder, which is nothing. But this one wasn't a remainder yet. So look at the difference between these two zeros. This one we brought down, and so you still have to do that one step. 55 times what number is close to or equal to this. But this is where you have no more numbers to bring down. That's finally your remainder. You cannot circle a number until you have no more numbers to bring down. So in other words, our quotient is 30 and not 3. Just be very careful with that. And this is why we also double check our work. If we were to do 55 times 3, we would only get 165. And keep in mind, when you multiply your dividend by your divisor, you have to get your divisor by your quotient, you have to get your dividend. So our quotient is 30, as you could see. The only difference is make sure that we multiply it. 55 times 30. And remember, you could have done, because of the commutative property of multiplication, you could have done 30 times 55. 0 times 0 is 0. We're going to multiply everything by 0 because it's the bottom right number. 0 times 5 is 0. 0 times 5 is 0. Now we're going to do the second number, the 3, by everything on top. And it's the second number, second row. Put a placeholder 0. 3 times 5. 3 times 5 is 15. We put the 5 here. Regroup the 1 on top of the next number we're going to multiply, which is this number. We're going to do 3 times 5, which still is 15, but this time plus the 1 is 16. When we add 0, 5, 6, 1, comma, 1, 2, 3, comma, 1,650 equals 1,650. If you were to have done 55 times 3, you'd only get 165, and these are not equivalent. So you would have known that 3 wasn't the right answer. It would have been 30. Okay, I hope that helps. Now I'm just going to help you get started with the word problems, but, you know, we don't have to necessarily do every single word problem. I mean, in terms of solving it, just setting it up. The factory workers make 756 machine parts in 36 hours. Suppose the workers make the same number of machine parts each hour. How many machine parts do they make each hour? So in here there's a factory and they're making things. If you know the total that they're making, that will go on top of this part-whole model. And you could see here, let's read it again and see if there's a total. If not, we're going to put x equals the total that we're looking for. So if we know total, it goes on top. If not, that's our x. Let's read it again just for the total. The factory workers make 756 machine parts in 36 hours. Suppose the workers make the same number of machine parts each hour. How many machine parts do they make each hour? There is a total. The total is the 756 machine parts for 36 hours. So your total goes on top. It's not unknown. It's not an x. Your total is 756 machine parts are made in 36 hours. So it takes them a whole 36 hours to make 756 machine parts. Suppose the workers make the same number of machine parts each hour. So here's one box and it represents hour 1. Here is the next box. It represents hour 2. And so forth. How many machine parts do they make each hour? Do you know how many hours they're working? If so, that's how many boxes we have. Let's see. Let's look for how many hours they're working. The factory workers make 756 machine parts in 36 hours, which means we're going to have 36 boxes. You could draw all 36 boxes, but I'm just going to put hour 36. But you could draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, all the way up to 36 boxes. I'm just going to draw an arrow and say there are 36 boxes. Do you know how much is inside each hour, each box? That means in 1 hour, do you know how many machine parts were made in 1 hour? Let's read it again. The factory worker makes 756 machine parts in 36 hours. Suppose the workers make the same number of machine parts each hour. They didn't tell us this amount, but it's the same. How many machine parts do they make in each hour? That's what they're asking. In 1 hour, hour 1, how many did they make? You don't know. That's what's asking, how many. So we don't know. That's our X. But it also says it's the same number of machine parts each hour. So hour 2 is the same amount as hour 1, so it's the same letter. And it's the same letter. And this is what you don't know. The X is the total machine parts in 1 hour. So here you could see that we have 756 as our total, and 36 is a part, and we're looking for the other part. Because we have a total, the number is getting smaller, and you could see here that's the total, and then these numbers are going to be the ones smaller to it. This number plus this number plus this number plus this number 36 times will equal 756. So 756 is our total. We're not adding to it. In 36 hours, 756 are made. We want to find out how much is made in 1 hour. So since our number is getting smaller, because if 756 is made in 36 hours and we want to find 1 hour, it's definitely going to be less than 756. We're either going to add, subtract, multiply, or divide. Which two operations get smaller? Because 756 is our total. It's how much is made in 36 hours. So how much they can make in 1 hour is going to be less than 756. Addition gets bigger. Multiplication gets bigger. So it's either going to be subtraction or division. And you could do 756 minus 36 minus 36 minus 36 minus 36 all the way until you get to 0 and count how many times you subtracted 36. Or because you're repeating the same number, you could just do 756 divided by 36. So go ahead and solve this one, very similar to how we've done it on top, and then you'll find your answer. So this one I'm just going to help you set up what you need to find on your own. You could pause the video at this point while I start number 14. I would highly recommend to pause it and continue when you're ready. One bag holds 12 bolts. Several bags filled with bolts are packed into a box and shipped to the factory. The box contains a total of 2,760 bolts. How many bags of bolts are in the box? So something's being shipped, and they're bolts. And bolts are kind of like screws. So when you're saying bolts, they're kind of like little screws. They're kind of like a part of something. They're shipping all of these parts, but they're putting them into bags. You know, you don't want to just have a ton of screws, bolts laying all over the place. So let's read it again and see if we know a total. The total will go on top. One bag holds 12 bolts. Several bags filled with bolts are packed into a box and shipped to the factory. The box contains a total of 2,760 bolts. How many bags of bolts are in the box? So the total goes on top, and they tell you the total is 2,760 bolts. So there are 2,760 bolts total in the box. Now, this whole box is shipped with 2,760 bolts. But it's not just shipped in one big box. Inside the box, there are little bags, and each bag holds these bolts. So, let's pretend that this is bag 1, bag 2. Do we know how many bags there are? Because if so, we could put that down here. So let's read again and see if we know how many bags there are. One bag holds 12 bolts. Several bags, it doesn't say how many, filled with bolts are packed into a box and shipped to the factory. The box contains a total of 2,760 bolts, and they're asking how many bags are in the box. So this is bag question mark. We don't know. This is what we're solving for. This is the X that we're looking for. X is the number of bags in the box. That's what we don't know. Now, how many are in each bag? Let's read again and see how many bolts are in one bag. One bag holds 12 bolts. So inside of here, there's 12 bolts. 12 bolts. 12 bolts. So you can see here we have a total. If there's 2,760 total bolts, and each time we're taking away 12, minus 12, and putting into a bag. Taking away 12, putting in a bag. Taking away 12, putting in a bag. Because we're taking away from this total, it's getting smaller. So between adding, subtracting, multiplying, and dividing, we're going to get smaller. And the two that get smaller is subtraction, division. Because we have a total of 2,760 bolts, and we're subtracting those bolts into smaller. We're taking 12 and putting into smaller chunk. 12 into smaller chunk. We're not getting a bigger number. We're getting a smaller number. You could subtract 2,760 minus 12, minus 12, minus 12 until you get to 0 and count how many times you subtracted. But because you're subtracting the same number each time, you could just do 2,760 divided by 12. Now I do expect you doing this on a separate piece of paper, both showing this work and whatnot, only because there's not enough space here. You could see even just doing the equation will take about this much, and you do still need the picture box and the equation. So I hope that this helped you. If at any point I went too fast, you could rewind. Another thing is you could just ask questions during class tomorrow. So good luck with the front and the back, and I hope you have a good day.